Hey guys, welcome back to the starter series. It's been a very long while since I made the last video for the series, and I decided to change the course of the next episodes since instead of going through the original schedule, which was making a new feature using the liquid stardust, instead I want to I want to answer a question that I discussed with someone in the comments and on Discord, which is about offline progressions with idle games. So yeah, it's a bit of a shame that I didn't address this yet, even though I kind of made some research on the subject. But this project, the starter series, isn't the best way to show you the offline progression. I will give you a few pointers of what you can use to have better offline progressions because in this episode we will be doing something very basic, very simple, and that will not work for every features of the game, right? It would be very long, and I honestly don't want this episode to be like 5 hours long if it is what it takes. I have no idea how long it's gonna be. So before anything, let's just visualize what is necessary to have an offline progression in our game. So I'm going to use I want to say visual thing to see what we will be doing in this episode. All right, so here are the two things that we will be doing in this episode, right? So first, we need to care about the time that was spent offline, right? So we'll have to take care of this. And the second point that we will deal with is the resource generation that happens when you start the game after offline time. Let's expand those two ideas to see how it's going to evolve. Right, so here's the full visualization, I guess. So for the offline time, we want to do two things. The first one is to save the time in the data when we basically save the game so that when we load the game, we get that the time when we load the game. And with that, we can make a simple calculation that will allow us to know how much time has been elapsed since the last save and basically when the game was closed. From there, we just get that time and generate resources based on the time. And this is where it gets a little bit complicated with the game because if you think about nebulas, which basically consume things, generate things, convert things, and the sifting games, which basically do things every X seconds. Um, that's the kind of things which you, in theory, can calculate, but that can get complicated, very complicated. So for this episode, what we will be doing, we will be focusing on generating more stardust based on the stardust generator, right? Because the stardust generator is just a simple amount of stardust generated per second, right? So that is very easy to calculate. So that's what we will be doing. So let's do all this in Godot right now. First, we need to understand how time works in Godot. So what we're going to do is just watch the time object that we can use. And we have this absolute monster. So there we go. Here, we can see that we basically have tons of different ways to manage time. We can use date strings, which are basically, year, month, day, and hour, seconds, etc. But what we will be using is the very last one, which is get Unix time from system. So this one is often used for many things because it's actually quite handy when you understand how it works and since it is just a number. So it returns the current Unix timestamp in seconds based on the system time in UTC. So basically, if I sum it up, because it can be kind of confusing, there was a date which is, I think it is, yeah, this one, right? 1st January 1970. And the Unix timestamp is the number of seconds passed since that date, right? So the point is that you will get, I mean, every seconds that happens in real world right now, that number is increasing by 1. So it is just a huge number that represents the amount of seconds elapsed since 1970. It's actually not that big, even though it is quite big, but it's not that big. And it's actually very easy to use it. In this method, the result that we get is a float. To be fair, it's not necessary to have this amount of precision, right? Um, and we will actually use an integer, as someone pointed that I pronounced this wrong. So yeah, we will use integer as it's easier, and we had some problems with the save, so when using floats. So we will be using integers, right? So now that we basically understand how this works, right? That's a number that increases every second. So basically what we will do, very simple, where is it? There. We will just save that number, and when we load the game, we will get the new number, which is going to be just a bigger number, and we can make a simple difference to get the time since last save. That's basically what we will be doing. So if we want to do this, we first need to create a slot in data to save this, right? Um, okay, let's have a little more spacing and create a line right there, which is going to be save time of the last save. Could be phrased better, but so it's going to be bar save time, and I want this as an int, and by default I want this to be -1 to say there's no save time, right? Okay, so we created a slot for this. So now we actually just need to save the time whenever we're saving the game. So as far as I remember, the save timer is here, so we have this there. Let's see. On save timer, we want to save system dot save data. All right. So maybe we can have this in the save system. Let's see. Where's the saver? Okay, so we will just have this game.rev.data.save time, and we want this to be an integer, right? Very important because the method returns a float. And we want to grab the time.getUnix from the system. All right. So now the time is saving every time we save the game. Maybe I can just simply try to run the game, get a save, and show you what it looks like. Right, so here is the save line, and there, right there. As you can see, we have a save time, which is a big number of seconds, and that's what we're gonna use, right? So basically when we load the game, we will generate a new one, which will be bigger, and from there we will be able to make a simple difference. All right, so let's go back to the game. What we need to do is to basically do something during the load. So we load the game right there. All right, reload the game here. So maybe we can try to make a method which is going to be offline progression. So where can we have this? We can have this in the save system maybe? since that's what it's just saving and loading. Do we want the, all right, so basically you will choose where this offline progression thing makes more sense to you. Maybe it makes sense to create a new class just for this. I'm I'm gonna have it there. Let's have it there in load. So static function offline progression. So what we want to do is basically check that we do have a save time. Okay, so if game.ref.data dot save time is inferior or equal to 0, we basically want to return because there's a problem. All right. Then we want to grab the current time. So we're going to create a load time, which is going to be an int. And just like the other one, an integer of time dot get uniques from system, like this. And we're going to make another check, which is if load time. Oh, let's actually get the save time. So we'll have save time. Do we actually want this to be invariable? Interesting. Yes, let's do it. So we want the save time to be game.ref.data.save time. So if load time is inferior or equal to save time, again, we want to return because there's a problem. All right. Then, now that we know that we have both a load time and a save time, which are load time superior to save time, we just want to have delta time, basically. And that will be an int equal to load time minus save time. Right, so now we do have the amount of time that passed between the saving and the loading. Maybe we can try to give it a cap, a max amount. That could be interesting, right? So you don't want, for example, the offline time to be higher than 24 hours or 88, something like this. Let's have this thing. So if delta time, well, let's have this bar, not like, we want this to be constant. We're gonna have constant, which is max offline time. That's gonna be an int. And it's gonna be equal to 360, which is the amount of seconds in a day. Wait, what? What was? I don't know why my brain bugged me. So yeah, that's the amount of seconds in an hour, and we want to multiply this by 24. Okay, so we do have a max offline time. Maximum offline time in seconds. Okay, and here we're going to check that if delta time is superior to max offline time, we want delta time to be equal to max offline time. All right, so here we have this function that basically returns the delta time since the last save. I'm just thinking a little bit because I think that will be game deciding what to do with that. So what we will do is return this value. So we will return delta time, and otherwise we will return 0. And that method will return an integer like this. So that's going to be offline time instead of offline progression. Now that we have a method that gives us the amount of time that passed since the last save, we can go back in the game, and when we are ready here, right? So it means that everything else is ready, which is pretty much what we want. We want to grab offline time, which is going to be an int, and we want this to be SaveSystem dot offline time. All right. So that comes after the add side there. So maybe actually we can create a method that's going to be offline progression right there. Offline progression. This is going to be void at the moment. And we're going to grab this line and paste it there. All right. So we have the time in our hands. So let me show you this. Where is it? Stardust generator. That's the guy I want. Here, I saw this mistake last time, which is moving this value right there, where it's supposed to be, right? So in the stardust generator, we basically have the generator power, which tells us how many stardust are generated each second. All right? Everything else isn't very important really, because all we need is to calculate the time. So let's go in the game here. We have the amount of time, the amount of seconds. We know how much stardust we generate every second. So what we're going to do basically is have a variable which is going to be generated stardust. That's going to be an int. And here we will have handler stardust generator dot ref dot generator power that we will multiply by offline time. We multiply the per second with the seconds to have a stardust. Right. So we have an amount of stardust which we generated. So what do we do here is we create those stardust. So we have the ender stardust handler. And here we will just use the create stardust method to create the generated stardust. All right. I want to make quite a simple check here because we returned 0 sometimes. So we want to check that offline time, if it is inferior or equal to 0, we want to return like this. So that we calculate and generate status only if we have positive offline time. The reason why I want to do this is for the next step, which is giving a visual cue that we generated stardust really. So now, do we want to check that this works? Well, it won't work as long as we don't have this offline progression invoke here. But yeah, let's create the visual interpretation of this. Basically, what I want, let me show you. What I want is that when we start the game, we basically have a pop-up that tells us, hey, we have generated X amount of stardust while you were away. So let's create this in a new scene. That's going to be good. So here we're going to create a control scene, which is going to be offline progression window. Pop-up window. I don't know. That's going to be offline progression window. So annoying. I don't know what to put there. So it's going to be offline progression window. Let's save it in scenes and user interface. No components. Yeah, components. And that's going to be offline. It's not a component at all. But here we go anyway. So we save the scene. All right. And what I want to do basically is it's going to be a popup. All right, so it will take the entire script, and basically we want it to disappear when we click somewhere on the screen. So what I will do is change this to a button, basically a texture button that takes the entire screen. All right, and that texture button, I will create a script and I will say that when you press the texture button like this, I basically want to queue free. Queue free, which is the Godot method to say delete this node. And since the script is attached to the root node of the scene, everything that's going to be in the scene will be deleted or freed, basically. All right, so we do have a huge button. So now maybe we can, we will add a kind of a layer that will act as an opacity to have a gray veil in front of the rest of the game so that we know there's this pop-up in front. So I'm gonna create a new node, and I think we can put a color rect like this, and we will design it to be transparent and black like this. It's gonna be cool. Random amount, random value. Oh, that's 69. Okay, that's a random thing. And I want to make sure that this doesn't stop the mouse click, because I want to basically destroy the pop-up when we click the area. And if I put something in front of it, it's gonna block the mouse. I'm explaining this because I honestly can't remember if we went through this in the starter series. So if I did, I'm sorry. At best, that's a quick reminder. So yes, we don't want the color rect right there to block the click and prevent us to click the button which is behind it. Let's have a panel now. A panel which will be the block basically that will display the text saying, hey, we generated something. So it's going to be, let's have 84, well, 800, 400. So good number. All right. So we're going to have this. And I will actually change the theme of this. So I will change the theme override to add a new style box flat. All right. And here we will edit this box. So let's go in there. And I actually want to keep the color of the panel. So I'm just going to create a small panel here, get in the new one so I can color pick the color of the panel and get rid of this guy. All right, so we have the new panel here. Let's create a corner radius of 8 pixels on each side so that it's a little bit rounded. It's always cool. And can we have something like a border? Yeah, border white. Let's have a, if I put 2 pixels, is it too big? It looks okay. It looks okay, I guess. So that's gonna be like this for the moment. All right. Do we want to save this? Yes, let's save it so you see how to save those kind of things. So we save this style box in a file, and that's going to be in the assets, and we will have those. Let's have these styles, themes. Let's have these styles, and that's going to be, hey, that's just going to be panel. panel is alright. I bet you can hear my sinuses getting blocked as I'm talking with my nose. It's very annoying, not gonna lie. So anyway, panel. Here we just will make a margin to have things a little bit smoother. That's gonna be a 32 on each side. And I will add a vertical box so that I have a title and a body, basically. In fact, huh, that's gonna be fine. Let's have this B box here. All right, in there I will add two labels. First one, which is gonna be the header, and that will be offline progression. Of course, we want it to be center, and we want to change the theme override, the theme variation, sorry, to header large. I will actually add a rule, so it's a separator, all right? And I'm gonna add another label, I guess. I will change the spacing to 16. And that label, which is gonna be the body, will have a layout, container sizing, expand, like this. So now I can center my label and give it the text. Okay. X stardust were generated while you were offline. Okay, that's quite a big box for a small text. That's okay. Oh, right. So, this is the component that we will basically create whenever we generate stardust. And I just realized that I didn't remove all the mouse filters. So I'm gonna check each and every one and set them to ignore. I'm not so sure about how pass is supposed to work, so I'm just gonna set everything to ignore. Oh right, the separator is a stop. Interesting. Okay. So here we need to know what is x, right? The value x must be defined. So we need to create basically a function which is going to be initialize, or no, it's going to be set, yeah, set stardust, set generated stardust value. And here we have generated stardust, which is an int, and that's going to be a void method, right? And what we want to do basically is have the body, right? Let's have this a unique node. So we will have var text, which is a string equal to generated stardust. And I don't remember the tag, so I'm just gonna copy paste it like this. And there we go. So we have the text, and then we go with get node, and then body dot text. Okay, it's actually do this properly. So we need to type this as a label to remind them that there's the text value. And we want to assign the text. That looks okay. All right. So now, from that point, we have a pop-up that we can display, and we just need to instantiate it, create it from the game right there when we do have offline progression. So here we will create a new reference to the offline progression fact scene. So that's going to be an export var scene offline progression. Of course, fact scene. All right. Let's assign it right away. Offline. Let's go. And now that we have this, where is the offline progression? Right there. So we want to create a new node. So that's going to be node, which is, oh, wait a second. I think I didn't type this. Yep, I didn't type this. So that's going to be offline progression components. Okay, so now it's the we have a slight discrepancy between the name and etc., but we can deal with it. Can we? We can. And minus. Back to game. We can now type this to offline progression component. And that's gonna be scene offline progression dot instantiate as offline progression component. And it's too big, so I'm gonna break the line like this. All right. So we have the new node. And now that we have the new node, we want to set the generated stardust value to, you know what, generated stardust. Like this. Okay. And now that we initialize everything required in this node, we can simply add child and add the node. There we go. Can we get rid of this error? Thank you. And we have few things in the debugger. Alright, that's something we can ignore. So we're gonna clear this. Alright, we have done pretty much everything now. I guess all we have to do is to start the game and try. So let's try this. And there we go. We have generated 11,000 stardusts while we were offline. So that's pretty cool. Maybe I will increase the veil opacity, and I should be able to click anywhere to get rid of this. Yes, thank you. So let's go in the panel, the correct right there, and increase the opacity a little bit like this. Let's try again. Okay, that's a little bit better, I think. Yeah, and 210 stardust. Do we want to put an S in there? Maybe. That would make sense, I guess. Let's just stardust. There we go. Right. So that's it for this episode. Oh, again, the exact same number. That's odd. I hope you like this. Oh yeah, sorry, I forgot. I want to talk about the other offline progressions in this game. So the nebulas here, they have their own timers. Maybe we can go in the nebulas to see that. Well, actually, it's right there. Here, this timer is the base timer of Godot, and it doesn't allow us to skip time or to fast forward. It's only able to work with real time, which is kind of lacking if you're playing with an idle game where you have things like increased speed, like game speed times 2, times 4, times 8, or when you have things which will skip time, right? A warp time method. If you want to go deeper in this subject, what you can do is go find the generator video that I did, because a huge chunk of that video is dedicated to make a new and improved advanced timer node that you can use, and that timer node has both the change of the time speed and as well as the skip time and warp time methods. The reason why it's going to be very important is because you can basically get the offline time and loop through your timers and skip times on all your timers, right? So if you want to dive deeper in that, you have this generator video that you will find somewhere up. It probably already disappeared, but you get the point. It's everything I have to show you for this episode. I hope you liked it. I hope you liked seeing this series back, and I will see you in the next videos, hopefully with my sinuses less obstructed. Bye bye.